Welcome back to this Rollon Tech Talk. I'm Jacob Rinda, and today we'll be discussing misalignment in linear motion applications, how misalignment could be increasing the cost of ownership of the machines you build or use, and how Rollon's self-aligning linear motion systems can reduce the cost of misalignment during machine design and operation. In precise motion applications requiring more than 50 microns of repeatability, such as CNC machine tooling, very high precision rail, such as Rollon monorail, is needed to position payloads. This style of linear guide is also known as square rail or profile rail. Specifications vary between rails and manufacturers, but when multiple rails are used in parallel, they generally require about 30 microns of flatness and 130 microns of parallelism between the rails, or they will suffer premature failure due to misalignment. Now, achieving that requires expensive machining or grinding of mounting surfaces. Those surfaces must be carefully cleaned and in many cases verified for straightness and flatness with each other with a laser or coordinate measuring machine. And these mounting surfaces must be almost perfectly rigid, both during assembly and over the lifetime of the machine. Now, if the guides are misaligned, the blocks induce force on each other. They fight each other as they travel down the rails. That uses up a portion of the load capacity of the bearing, greatly reducing life. It also causes binding, damage to the rails and slider blocks, and can sometimes even shear the fasteners used to mount the rails to a machine. And while it may seem intuitive to upsize the guide to overcome those issues, the rest of the system will then have to be upsized as well. So, overcoming misalignment when using profile rail results in either increased cost upfront in machine design and manufacturing, or increased lifetime costs due to maintenance and warranty returns. All told, for this style of rail, misalignment is expensive. However, in almost all transfer and automation applications, 50 microns of positioning precision isn't required. For the majority of linear motion applications, a 150 micron precision self-aligning track roller linear guide like Rollon Compact Rail is likely suitable and will reduce the design, assembly, and maintenance costs of linear guide systems when compared to profile rail. Rollon Compact Rail and Compact Rail Plus feature various rail and slider arrangements to accommodate misalignments. In larger sizes, Compact Rail can absorb up to 50 millimeters of parallelism misalignment and 2 degrees of slider tilt caused by height misalignment. Compact Rail is 100 times more compliant than profile rail, meaning that mounting surfaces don't have to be machined. That alone can drastically reduce cost and save time. Mounting surfaces also don't have to be inspected for flatness or parallelism, reducing cost and saving time during design and assembly. Machine bases can be much less rigid, allowing lower cost materials to be suitable mounting surfaces, like moderate gauge sheet metal and aluminum extrusion. And finally, rails can be floated into position while remaining within mounting specification, eliminating the need for alignment lasers or coordinate measuring machines and reducing the number of personnel needed for assembly, saving time and reducing cost. If you'd like to know how to select the Compact Rail T, U, or K rail combination that will save time and money in your next application, check out our Compact Rail Tech Talk linked in the description below. And for more information on Rollon's misalignment solutions, including catalogs and CAD files, or to get in touch with an engineer to design a linear motion solution to match your requirements, reach out to us at rollon.com. And if you like this video, please click the like button and subscribe. Thanks for watching.